programming is for people. And the best ways that we have of making sure that we can build software, that should be what programming is. And ultimately, it should be widely democratized. It should be available for artists and designers and middle managers or whatever it is. They should be able to use these things as easily as possible. I want this as wide as possible. Now, building software for yourself, it's a means of empowerment and also excitement and delight.
Welcome to the Work for Humans podcast. This is Dart Lindsley. Sam Arbesman writes deep, beautiful books about the boundary between technology, knowledge, and, for lack of a better word, wonder. His most recent book, The Magic of Code, is another profound exploration, this time into the wonders revealed by code. He describes software as a universal force, swirling through disciplines, absorbing ideas, and connecting worlds. I wanted to talk to Sam specifically about the experience of coding. This is an important and rapidly transforming part of the world of work. What makes the experience great? What makes it dreary or arduous or frustrating? When does it provide a glimpse into the eternal? When is it beautiful or mysterious or magical? And how will AI change that experience? Sam is a complexity scientist, computational biologist, and applied mathematician. He is also an extraordinary communicator, able to make these complicated ideas accessible. Sam's the author of Overcomplicated, Technology at the Limits of Comprehension, and The Half-Life of Facts, Why Everything We Know Has an Expiration Date. He is scientist in residence at Lux Capital, a venture capital firm investing in emerging science and technology at the outermost edges of what's possible. Before joining Lux, he was a senior scholar at the Ewing Marion Kauffman Foundation and a research fellow at Harvard. His work has appeared in the New York Times, The Atlantic, Wired, and Harvard Business Review. If you enjoy conversations that stretch your mind and deepen your understanding of work, be sure to subscribe. And now, here's my conversation with Sam Arbesman. Sam Arbesman, welcome to Work for Humans.
Thank you so much. Great to be chatting with you.
I was just at an HR conference, and in this HR conference, the conversation was largely about people at work, talking about them as pure inputs to production and as a problem to be solved. And it was almost like everybody was trapped in the idea that people at work were like cords of wood that needed to be stacked and managed and split. It was very, very far away from the experience of work. And on this show, we're about the design of work, so we're very much about the first-person experience of work. And you have written a really beautiful book about code. It's not the first beautiful book that you have written. And in fact, you write books on very esoteric topics, math and the limits of comprehension, and they get awards for being beautiful.
Well, thank you. That's very kind.
And so I want to talk to you about your most recent book, which is The Magic of Code. And I want to explore when it's wonderful. I want to explore when it's not. But where I want to start is your exposure to code. Your degree is in computational biology. You're not like a full-time coder, but that work and work that you've done since then has exposed you to a lot of coding. So how does your work pull you into coding and involve you in it?
Maybe I should also start with a little bit how I first got connected to the world of code. My father, he's a retired dermatologist. He happens to also have been a fairly early adopter of lots of technology. And so when I was very young, my father got a computer, like a personal computer for our family. It was the Commodore VIC-20. It was really basically just this blocky looking keyboard that had the computer inside it, connected to your television. You had to store information using these cassette tapes, use the Commodore data set to work with it. I never really programmed that. I was too young to program it, but I could see a clear relationship between code and what actually happened on the screen. Because one of the common ways in which you actually got computer programs in those days was not necessarily purchasing software. You would actually just type it in yourself. You would manually type it in based on several pages within a computer magazine or a book that you might find. And so my father would do this, and he got games for us by typing them in manually. And I can actually remember very clearly, he would enter in lots of code, And I would see the clear relationship between what he wrote and what actually happened on the screen. Sometimes it would work. Oftentimes it would be like a screen of gibberish because that was just the nature of bugs and glitches. But I saw that clear relationship. And eventually I wanted to do this thing myself. And so after the Commodore VIC-20, we got one of the Macintoshes in the 1980s and then eventually got more. And one of the pieces of software that came with the Macintosh beginning in the late 80s and I think through the late 90s or so was this piece of software called HyperCard. It's this kind of wild piece of software that you made stacks of cards, which is weird to describe, but basically the way to think about it is each card is an individual screen or an image or a page, and you're building up a series of web pages for an entire website, which is the stack, but they all live on your own computer. And the one interesting thing about HyperCard was that you could easily just draw in it or write in it and store information. But under the hood, it actually had a lot of computational power. There's actually programming involved in it. And so there was actually this language called HyperTalk. So you could very easily, even without knowing that language, throw in a button, have that button do some interesting things. But then underneath it, you could begin adding more and more text. And so there's this great phrase attributed to the computer scientist Seymour Papert. He was involved in the creation of the computer programming language Logo. He talks about this idea of low floors and high ceilings, the idea that you want software that can easily allow entry for a beginner, but allow a great deal of open-endedness. And for this kind of software, for HyperCard, it really did that. It allowed me, who didn't know how to program, to begin playing with this and then eventually learn how to program. And then after that, I began using more traditional languages, like I think maybe I used some version of Pascal and then C and C++ and then Java and then Python, and then slowly but surely began actually having this experience of programming a lot. But in terms of my own work, as you noted, I've never been a professional programmer. I've always had some sort of amateur flavor to it.
I'm going to say that's not exactly true.
Okay, that's fair.
It's not exactly true. It's just that you use it as a tool to get things done in your world.
That might be the better way to describe it.
You're not a hammer maker. You use the hammer.
Yeah, that's a really good way of describing it, because I definitely build software. But you're right, it is in service of analyzing data or creating a simulation or a model or things like that. Because for my PhD, I have a PhD in computational biology. I got my start actually doing evolutionary models and trying to understand computational mathematical models related to evolution. Very quickly, though, I began getting interested in the whole realm of complex systems and complexity science, kind of using computers and mathematical models to understand large systems of a huge number of interacting parts. So whether or not they exist in biology, so it could be like the cell has a huge number of proteins and various other things all interacting. It could be the level of an ecosystem. It could be within a technology. So the entirety of the internet is a complex system. It can be in social systems, so groups of interacting people. It could be a society or a city. These things are all complex systems. And it turns out if you abstract away some of the details, although the details, of course, are very important, if you abstract away the details, you can learn a lot of really interesting features of these systems, even though they might be wildly different, at least on the surface. And it turns out a lot of the mechanisms for understanding complexity science and understanding complex systems involve computational models. And so I began to build these kinds of models in service of trying to understand these systems. And so I have done a lot of computer programming in service of these kinds of things. Interestingly, the programming that scientists do is seldom pretty. It's very utilitarian, or I would say it's utilitarian in the sense of it gets things done. It's not necessarily for the purpose of someone revisiting that software at a much later time or being part of necessarily a very large software project. So it's a different kind of programming. Sometimes it can be. And I think the scientists who actually try to build software that is more in service of being used by a larger audience is actually a really important thing. And sometimes academia does not necessarily promote that kind of thing because those are not necessarily the things that get you tenure. But I do think we need more of that kind of thing. And so I've used software for all sorts of things in my daily work.
What software languages has this exposed you to?
Throughout my professional work, I'm trying to think of the different languages I've used. Certainly, by far, the one I'm most comfortable with is Python. That being said, I have also used MATLAB at various points. I've used R, although I don't particularly enjoy that, but that's a really common language for a lot of data munging and manipulation. I began using Python, now that I think about it, probably over 20 years ago. The language has been around for a very long time, but that was fairly early on before its, I think, increase in popularity. I've used Perl. I definitely learned Java in college. I don't know if I actually used it for some of the research kinds of things, but it's really more whatever language is necessary to get the job done.
And you actually have a list in the book, and there were things on that list I'd never heard of. Most of them, I guess, I had, but it was like a dozen.
There are a lot of, and the one interesting thing about programming languages is, by and large, there's only a few types. And so once you know one within a category, it's very easy to pick up another one. And as long as you can just easily search online for, oh, how do I do this thing? Or what is the specific syntax? You can muddle your way through things. And certainly now with generative AI, it probably makes it even that much easier to use various different languages. But I would say the two major types of programming that I've done are the imperative, more traditional programming where it's just a list of instructions that the computer follows through. That's like a C-style program, things like that. The other type, which I learned in undergrad, is more like the functional programming, so like Lisp or Scheme, which is very interesting. And it also required me, because I was not familiar with it up until that point, to almost rewire my brain to a certain degree. And I found that fascinating, the fact that there are these different modes and they provided different lenses for how to think about the world and ideally for how to actually build software and engage with the world.
Your book is all about wonder. And I know that there's a part of coding that's drudgery, but I want to talk about moments of wonder and pick which one you'd like to talk about. We're going to talk about a couple. I don't know which ones they're going to be, but a part of the way you write about it is using the language of magic very often and of mysticism and the ways in which code is an incantation, that you voice these words and something happens in the world. So I assume that there was an evolution to your wonder. What was your first wonder?
My first wonder. Ooh, that's wonderful. That's a really good question. I'm not sure. I would say, given my focus on this idea of magic, it probably was the first time that I wrote some program where it either wrote some text or it generated some image on the screen, and it worked. So for me, and that thing of being able to use text and actually have it operate in the world around us, as I mentioned in the book, we've talked about these ideas for millennia, probably, this idea of text to engage with the world around us, to build spells or incantations or whatever. And only really in the past 75 years or so has this been a reality since the modern advent of digital computing. I mean, there have certainly been wonderful interactions with computers, but in terms of when it comes to code, I imagine it has to be early on when I built certain types of software. And so I would say one thing that I've always found very interesting is the world of the screensaver. This sounds a little bit trivial, but the idea behind the screensaver, I mean, it's really just meant to, back in the day of cathode ray tubes, that screens did not have burn-in. If a static image was on the screen for too long, it would create this ghostly memory of whatever that was. And so to prevent that, the screen would go black, or there would be some sort of changing image on the screen, or graphic or visualization, and that would be the screensaver. But one of the interesting things about screensavers is that they were early instances of this idea of creative coding, the idea that you could use maybe a combination of mathematics or randomness or whatever it is to create these aspects of unfurling complexity. And so whether it was some swirling image that was actually defined by mathematics, I found those things very, very interesting. I always wanted to make that kind of program. And so I imagine maybe one of the first experiences of wonder was actually building something in that style, whether it was falling snow or flying through stars that are whizzing by, something like that, where I realized that you could use the iterative power of the computer. Because one of the interesting things about computers and microchips and everything like that is they're not smart. They're really just able to do lots and lots of things extremely quickly. But it turns out there's a great deal of power in this speed, that it creates this qualitative difference, that when you can do something over and over very, very rapidly, it actually will reveal something entirely new. And so whether or not it's stars whizzing by that I could never do manually, or it's some swirling image, or zooming into a fractal, which is this wild mathematical objects that are basically infinite in complexity. Those are the kind of things that probably really brought home certain aspects of wonder for me when it came to computing and computation.
Which is interesting because the thing about a screensaver is it can be anything. In other words, it's a palette. It's not like you're trying to write code that's going to make the garage door open and it's going to work or it's not. And you're not constrained in terms of what image you're going to display. And I'm going to touch on these as we go because there's certain things that I hear recurring in all of my interviews with people about work, which is that it provides them a creative medium. And sometimes the creative medium is business itself. I like to build businesses. But sometimes that creative medium is, I've got this open palette where I have some degrees of freedom to express myself creatively. But I would imagine that, like with all media, some are easy to work in and some are hard to work in. And I always think about the people who made frescoes. You know why frescoes went out of style? It's a horrible medium. You have to mix it in plaster and then you have to put it on the wall and then it's going to dry and then you can't modify it. So let's keep exploring the different kinds of wonder that you came across and we'll listen for these things. First of all, does that sound accurate?
I think it does. Certainly when it comes to like the screensaver, those kinds of pieces of software, there clearly was an element of play and fun there. Right? It's not just, you're not necessarily just solving a problem, although you're solving the problem of preventing burn-in. But there is a huge variety of ways of solving that. And in there is a great deal of creativity and openness and possibility for delight. And I think that's really important. But I think also what you were saying in terms of the different media and what they provide is when it comes to programming languages, there definitely is that. And I think everyone has their favorite language or their most comfortable programming language that they use because it often provides them the expressiveness that they want. Because when it comes to programming is certainly goal-oriented. And people sometimes try to analogize coding with literature. And in some ways, it actually can work out. The difference is, though, there's very different goals where you can write a series of lines of code that can be as beautiful as you want, but if it doesn't actually execute or if it doesn't compile, then it doesn't matter. It needs to actually work and it needs to also fulfill the task. That being said, within there, whether it's within a certain language or choosing among different programming languages, there's a huge variety and distinctiveness of styles. There's actually this wonderful book. It's a fun kind of kooky book, but it's called If Hemingway Wrote JavaScript. And the premise of the book, if I'm remembering correctly, is they take a single programming task. I think it's maybe sorting a list, or I think it's finding the number of instances of words within a text file. And the author shows all the different ways you can do it. And it says, okay, imagine if Hemingway wrote that program, what it would look like. And it would be kind of very sort of staccato and simple. And then some other author, whatever it is. And it shows that I'm pretty sure every example is within JavaScript itself. So it's showing even within JavaScript, not even amongst different languages, that there are all these different ways of expressing yourself. And I think even though, and obviously programs just need to work and they need to get things done, there are still so many ways of programming or even just thinking computationally. And I think that's something that certainly outside of the realm of programming, people might not realize that there's an element of craft, there's an element of fun and delight. And actually, and going back to the world of magic, oftentimes when we tell our stories about magic, it's not just easy. It doesn't just happen. And even though we think of like, oh, it's magic, it just works. There's a great deal of effort involved. You might have to study 7 years at Hogwarts, School for Witchcraft and Wizardry, or wherever it is. It takes a lot of work. And even though it takes a lot of work, there is also a certain amount of personal expression as well. And I think we see a lot of that same thing in the world of coding and computation, that it requires a lot of effort to program, or it can. And then we can probably talk about democratizing some of these things later. But even within that, even within the realm of work, there are still many different ways of being an expert or being really good at your craft.
One of the shames, though, is that this is often a craft that is private. In other words, you're the only one who ever gets to see it. I did some work for my father. Interestingly, turned out to be very interesting to evolutionary biologists. But I became the world's leading expert in a very obscure corner of developmental genetics and built some things, some models that I'm the only person who's ever going to understand them, honestly. And it's almost like having visited a moon, around a planet, on another star, in the galaxy, and I'm the only person who's ever visited, and I can't even really explain it to anybody. And so there's a privateness, a solitude almost in some of the things that you might be proud of.
I think there's an element of that. Certainly when it comes to the realm of open source, or even just working within a larger group or within a larger company or a team, there is the expectation that what you are doing should be shareable, or at least somewhat understandable to others. Not necessarily just in terms of how it works, but actually seeing the thing itself. And there are many people who talk about, oh, certain types of coders, they have an elegance to their code, things like that. But you're right. It is not necessarily for everyone. There's certainly a distinction there in terms of writing. You write a novel, the actual work itself might be shielded. You will not see all the drafts and all the sweat and effort that went into it. You will see only the final output. However, the final output, there clearly is a relationship between the final output and the text itself, because in this case, the text is the output. Versus with a computer program, the text is often the intermediary for the eventual output. That being said, one of the interesting things when people talk about programs and programming languages and code is this recognition that they're not just for the machine. They're not just for the machine to run or to execute or to compile or whatever it is. There is this sense that they are for humans, even if it's just for yourself. And so one of the classic textbooks, Structure and Interpretation of Computer Programs, mentions this, I think, in the very first pages, this idea that software or code is meant for humans and only incidentally for the machine to execute. Because the idea is that you have to be able to write it for yourself. You have to be able to understand your own code. You might want to be able to share it with someone. You might want to have someone look it over. So I think this idea that, and yes, it might just be for yourself, but there's not necessarily anything wrong with doing something for oneself, even if the eventual output might be for other people. And I think there's something to be said for being able to work in a craft where the reward of a task well done is the output rather than the input. Not necessarily because you wouldn't want to share that, but I also think, and I'm working this out as we're talking, but I do think in the current moment with social media and the way in which people share everything so publicly, the fact that we can have some sort of task where the input is maybe not necessarily being shared publicly or is not necessarily being shared widely or understood as widely, that's okay. Because I think there's something to be said for being able to just do things without necessarily having to share them with everyone. That being said, I do think we need to make it easier for people to be a little bit comfortable with looking at code. And so one of the things I discussed in the book is, I actually even include this little snippet of code. There's very little code in the entire book, but in this little snippet of code, I say, don't look away. There's something interesting here. And you might not necessarily understand how it works, but you might get a feel for what code looks like or a feel for its shape. And I give the analogy of there was this period in Europe for several hundred years where people basically hated the idea of untamed wilderness. And people actually went out of their way to avoid looking at mountains or cover their eyes if they actually had to go through certain parts of the wilderness. And for us, that sounds very, very strange because we love these untamed wildernesses. We go out of our way to visit national parks and look at mountains, and these things are wonderful. And I wonder if there is a need for almost doing the same kind of thing that was done in those days, in the same way of almost rekindling a sense of wonder for wilderness. We might need to do the same thing for appreciating code. And to be clear, if I'm looking at classic bits of source code for, I don't know, the original version of Photoshop or whatever it is, I'm not going to understand most of it. But I think there's something valuable in at least encouraging people to not entirely look away, to actually recognize that there's something interesting there.
It was a funny moment in the book because you had that little tiny snippet of code. Right when I got to it, it was like I might skip over something written in French or Russian, you know? I just skipped over it. And then you said, don't skip over this. I was like, okay. And I went back and I started to look at it, and you start to be able to comprehend it. You start to say, yeah, I can see that it's got a syntax. And is there anything that you've ever built in code that you're particularly proud of?
That's a good question. I'm not sure, which I think is a long way of saying that when it comes to code, software and code, they're particularly evanescent and ephemeral. You write something, you might write it for a specific purpose, or you also recognize that maybe it'll become obsolete relatively quickly. And so I think there's something to be said for not holding on to anything too tightly. That being said, I would say, going back to the discussion around screensavers, some of my simple little visualizations were probably some of the things that I was most proud of, not necessarily because they were particularly beautiful or particularly powerful or groundbreaking, but they were things that pushed my own limits in terms of what I thought possible. So for example, when I was in high school, I took some programming courses, and for one of the classes, we had to do a final project. And I think my teacher told us that it was basically impossible to do anything visual. You had to write some sort of text-based program or text-based game or whatever it was. And in a fit of contrarianism, I basically said, okay, I said to myself, I'm going to try to build some sort of screensaver-like thing, even though I was told that it's not possible to actually do anything visually with this language. And I was able to do it. And I made this weird flying through outer space with stars kind of zooming by. And not only was I able to figure out how to do things visually, which I was excited by, but it also was a moment when I realized that trigonometric functions were actually really valuable for coding computer graphics. It was something that I had never really used before. I just thought we had to learn it in math class. And I suddenly realized that they were useful. And so it was this combination of doing something that was both outside of my area of competence, combining it with certain areas that I hadn't thought were related, and also doing something that my teacher had basically said was impossible. That all combined to do something, to create this piece of software that I was just very happy to have done, very proud of. Do I still have it? Definitely not. I have no idea where this is. And so going back to the ephemerality, I was very proud of having done it. I don't necessarily think it should have stood the test of time, but I can think back on how exciting that was to have actually accomplished that.
It's interesting. Writers have often spoken in a very similar way, which is they say, I don't want to talk about my old writing. It's footprints in the sand. It's my footprints. It's not where I'm going. But then on the other hand, you've used it to solve things that it wasn't necessarily the code that was special, but it was the solution and the discovery in the real world. So let's actually talk about some of the boundary between basically what working in code teaches you about the universe or exposes deeper truths about the universe.
The way I organize the book is I have these three sections spiraling outwards of code, kind of the nature of code, then thought, how it impinges on how we think and the nature of programming languages and natural languages. And then the final section is all about reality, which is obviously a overly grand task. But I try to explore the ways in which code and computation, going back to this idea of magic and kind of writing text that does things out in the world, in the same way, it can also teach us about the world itself. And one of the first examples I give is around this idea of simulation and modeling. When it comes to models of the world, for a long time in history, we've had two modes. We've had descriptions that are inert, so maybe like a mathematical formula that explains how a ball flies in a parabola. And then we also have physical objects, a globe, or the idea of the orrery, which is actually dynamic. It's this mechanical model of maybe a subset of the solar system where there might be the sun in the center, and then there's an arm that holds the Earth and maybe some other planets, and then there's another arm that holds the moon, and then you can actually crank it and it can kind of move around. I believe there's actually a Lego version of this that you can purchase now. And so there are these physical models, and then we've also had descriptions, whether it's prose description of the world or mathematical descriptions. And only since the rise of the digital computer, at least in my mind, have we been able to actually combine these two things together. Actually write textual descriptions of the world, maybe a series of differential equations or some agent-based model or whatever it is, and then that actually operates. It will actually create some sort of dynamic, tangible model of some subset of the cosmos, whether it's the solar system, whether it's animals interacting or whatever it is, or a fire within a forest. And I think that fact that we can actually encapsulate a certain amount of the world in code and in software is something both really powerful and something that we're also probably still grasping with and grappling with its implications. And so one of the things that I think about when I think about computers and computation is that a lot of the interesting trends that I think are happening now, whether it's AI or sort of simulations or whatever it is, a lot of those ideas were developed fairly early on in the history of computation. But then it took many, many decades to get to where we are to elaborate all these kinds of things. And when it comes to simulations, we are now in this interesting place where we have simulations that are increasingly more sophisticated than we ever thought possible, just due to the combination of better models, better data, as well as just unbelievably more complex and more sophisticated computation. The chips and the computers that we have, the computational power is much more. And so we can do lots of things. At the same time, though, we also have to grapple with the fact that simulations and models are not reality. As much as we want the model of the weather inside a computer to be exactly accurate or whatever, it decays within a certain number of days or whatever it is. And so for me, when I think about, at least in broad strokes, the relationship between reality and code, at least when it comes to simulations, there is this wonderful power of being able to create microcosms of the world around us within computers. But there is also an increasingly important need to recognize a certain amount of humility around these things, like recognizing that these things, they are not the real world. The simulation is necessarily some sort of simplification. And I think the lack of doing that, there are often problems when we fail to recognize that mismatch.
There's two things in there that I could look upon forever as a mystery of the universe and never run out of wonder. One is the gap between a model and reality. And so it was like decades ago that I was really bothered by the fact that how much compute power it took to solve protein folding and how much time that took and how quickly a protein solved the same problem. And I went around talking to my friends who were close to, well, biophysicists in some case, and I'd say, what is that gap? And most of them said to me, that question is nonsense. They said, the protein is not solving the problem. I said, it absolutely is. And so finally, I spoke with Eshel Ben Jacob, who, gosh, you should know his work. You guys have moved in very similar, I think, intellectual realms. And he said, no, that's not a trivial question at all. The difference between those two things is that our math is nothing like how a protein folds. And in fact, he said, if the world worked like our math, it would take 1,000 years for a protein to fold, is what he said. And so I feel like models gesture
Exactly.
in the direction of truth, but are very far from reality in many cases. On Work for Humans, we've been exploring the principles of multi-sided management, which is the belief that work is a product that every company designs, builds, and delivers to employees. Along the way, people started asking how they could put these ideas into practice. So I founded the work design firm 11fold to help your company create the kind of work that makes teams feel alive and engaged instead of dead and dull. So you can reduce turnover and build commitment. We're doing something revolutionary here. Learn more at 11fold.com. That's 11fold.com.
And I think when we focus on just prediction, we often fail to recognize that models can have many, many different goals, chief of which is sometimes just gaining a better sense of understanding of some sort of system. A really good example of this is SimCity. The computer game SimCity is not meant to be a perfect model of a city. In fact, I imagine many urban planners would say that there's many, many incorrect assumptions within it. And so it's incredibly simplified. That being said, if you think about it as a tool for grappling with nonlinear complexity and systems that bite back or have unanticipated consequences, it's an amazing model. It gives you that sense incredibly intuitively. And it also was very valuable for getting many people who are involved in working on urban design or whatever it is actually started in their fields. They were inspired by SimCity. And so that kind of very simple model can actually have many, many good benefits entirely separate from recognizing that this thing is not actually modeling the world. And so recognizing that a simple model that maybe has many unreasonable assumptions, but can still give us a sense of why the system might behave in the way it does, that can be really valuable too. And so giving us some sort of insight. And I think this also just goes back to the fact that not only might our math not be the way the world works, but our minds are pretty limited. And so any sort of simplification we can latch onto, we should take, because we need those things to really understand the world. But going back to what you were saying about protein folding, I think there's also something really interesting there, because some people have talked about the computation of the universe itself. And so in a small version of this is the idea of analog computing, which is finding some sort of analog within the physical world that is doing some sort of computational task or some sort of mathematical task that you might want. And so whether or not it's looking at how certain gears operate or the way in which water moves through some sort of system that you can relate it to the way in which economic models might work, there are ways of mapping the actual physical behavior of physics, of reality, onto computation. But one of the things that digital computers is decouple those. And so one of the things that people are beginning to realize, and we can talk about this more if this makes sense, is realizing that there are lots of different ways of computing, of having computation in the world. And so actually, one of the things that people talk about when it comes to biology is that biological systems like cells and things like that, they're doing information processing, they're doing computation, but it's a very, very different kind of computation than we might do in sort of our traditional computers, which should lead us to recognize that the space of computation is actually much broader than we might realize, that there are all different ways of computing. Some are highly parallel. They might involve a huge amount of stochastic randomness that happens within a cell. And those are the kind of things that we don't traditionally have in our laptops or the computers we use on an everyday basis. But they can still actually be used for computation. And so thinking about the ways in which physics does computation, although I'm hesitant to say does computation because I think that might be a little too strong.
Solves problems.
Solves problems or does its thing. I think there's often a great deal of wisdom to be gained from these kinds of systems. But going back to what we were saying before, there's also a great deal of wisdom in having to recognize that the models that we build in our software and our computers, they have to be simplifications because there's so much about the world that we don't know yet. And I think whether or not it's simulations, whether or not it's recognizing the way in which we model the world is wildly different from maybe the world does its thing. This just speaks to the idea that the more we understand computers, I actually think, at least in my mind, the more we need to really grapple with vast amounts of humility, which is often in short supply when it comes to the more computational realm.
Yes. I mean, that's especially true when faced with biology. I mean, you talk about the way biological systems compute. To me, it feels like the way you described people looking at wilderness in the past, which is that the computation that we've invented ourselves, we can look upon and comprehend, but the computation that happens biologically is monstrous in its alienness, right?
Completely. And actually, the one interesting thing is that as we are building larger and larger computational systems, especially vast AI systems, people look to the same sorts of techniques that we interrogate biological systems. It's like when you are confronted with an AI system that does its thing, and it might have weird, unexpected consequences, or you're just not really sure how it does what it does, you have to often take a page from biologists and the way in which they grapple with this alienness that's almost Lovecraftian in our inability to really skim beneath the surface and really see what's going on there. That kind of approach, I think, is going to be increasingly powerful, but also just increasingly important of recognizing, okay, even the things that we have built ourselves, these really, really complex AI systems, they are going to need to be interrogated in the same way that biologists. And so I'm picturing like the naturalists of old who just collect things and discover things and find interesting ideas, or even more modern biologists who will study some very specific system, trying to understand how it does what it does or whatever, and then slowly but surely build up a more complete picture. These are the kind of tools we're going to need to use to understand the systems of our own making, which is wildly different from, I think, a lot of the ways people have traditionally thought about technology. People think of technology as this very pristine, logical thing. And there is a great deal of logic. But when it gets big enough, or when it combines with lots of other systems, or grows over a long enough period of time, and you're contending with legacy systems and all other kinds of systems, we need the tools from biology and these other sciences that are interrogating complex systems that are not of our own making.
It's a perfect example, just that riff right there, of the kinds of understandings of the world that working in code expose you to. Some of it is the limits of what's knowable. Honestly, the limits of what's computable as well. And it gives me, I don't know if it's giving you this feeling of walking around in the dark with a pen light and being able to illuminate little bits of reality, but humility about the dark.
Yeah, and I think one related feature that has given me a great deal of humility, but also has given me a sense of how to think about the world more broadly, is just the process of debugging and dealing with glitches and failures. Because, and actually, another example of wonder I can remember this, I think this also might have been in my high school computing class as well. I was trying to make some simple little game, and I made an error, and the bug actually was more interesting than the thing I initially wanted to do. And that gave me this sense of, oh, there's a lot of complexity that I'm only beginning to grapple with. But more broadly, debugging is a fact of life. Writing code is not a process of taking some idea in your head and instantiating code. It is that, but it also involves this clumsy plotting process of spending time figuring out, okay, what is the difference between the thing I thought I was writing and the thing that the computer is actually doing, and then trying to actually bridge that gap. But then oftentimes when we have really sophisticated systems, the only time that we learn how the system is actually working, how the piece of software is working, is when we are confronted with a bug. And we realize, oh, the thing I thought it was doing is doing something different. Or this system that maybe I didn't even program, when it fails, I gain a little bit of a window into what is actually happening, similar to that pen light. The failure shines a tiny little bit of light on what is actually happening within this computer program or this piece of software or whatever it is. And not only does that teach a great deal of humility, it can also teach you about the ways in which these systems are interconnected in unexpected ways, or the ways in which computers are actually much more deeply physical than we often think of them. And obviously computers are physical. They are real things. And the internet is a physical thing that interconnects the world. But we don't often think about software that way. And going back to the way I was talking about code, we talk about it as this weird word stuff that just conjures things and does stuff. And it does that. But it only is able to do that because of this physical infrastructure. And we often only realize that there is this deep physicality to computers when something goes wrong. So there's this well-known story around someone was informed that the emails of some university department were only able to be sent around 500 miles, which sounds insane because you think, oh, emails, they should go everywhere. And it turned out it was some weird thing with some old piece of software, and then it would time out in some very small amount of time. But it turns out the amount of time until it timed out, if you took that amount of time and multiplied it by the speed of light, you would realize, oh, it was about 500 miles. And so there was this weird interconnection to the speed of light. And there's other things where people look at how their Wi-Fi only works when it's raining because of some line of sight and with trees or whatever it is, or how helium atoms can actually get into iPhones, but not other types of phones. There's all these weird examples of the ways in which our machines are deeply physical. And so there's a fun book called Tubes, which is about the physical infrastructure of the internet. And it's based on, there was a senator a number of years ago who talked about how the internet is not like a dump truck. It's like a series of tubes. And he was mocked for it. But the point of this book is, no. In some ways, it is a series of tubes. There is a deep physical structure to the internet. And I think whether it's bugs revealing the physicality, bugs revealing the limits of our mind, or just these models more generally, helping us grapple with the complexity of the world versus the things that we're trying to understand. One of the things that I tried to include in the book is that, this drumbeat of humility, which is that when we take computers and code seriously, not only does it teach us a lot about the world around us, but it also shows that we are very limited beings And that's fine. That's great. And I think we can still do the best we can. But that's something that we need to really realize.
There's definitely a relationship between wonder and awe and humility. They're almost the same thing in some cases. So I want to get into the in-the-moment experience of coding, because there's a lot of times where there's work where at moments you get to stand back and see the wonder, but that's not the experience of the in-the-moment work. And in fact, I don't know, how unusual do you think you are in terms of seeing the wonder? In fact, a friend of mine in college, this was not that long ago, he was in a computer class, and the professor pulled him aside and said, "Look, why are you in this class? Do you want to write games or something?" And he said, "Are you a computer science person?" And he said, "No, I'm a music major. I'm just here because I think it's pretty."
I love that.
And she was like, "Oh my God, you must be in our department." The reason is his interest in code was A, he thought it was pretty, and B, he likes the arcane, and he likes to master the arcane. And so this idea of having this secret knowledge that's behind the world to him is really compelling. But that's, I think, not that common in the world of software design. And so it was kind of a combined question. So let me see if I can say this as two separate questions. The first question is, how unusual are you?
I guess it depends how you would categorize me. So within the realm of programmers more broadly, I probably am somewhat of an outlier in the sense that I mentioned before, like I'm not a traditional software developer. And I imagine the majority of people who are programming are coming at from that world. And so in that sense, there definitely is a little bit of an outlier feel. But I think there are many, many people who think about code and programming as this means of expression, going back to what you're saying of the arcane knowledge or finding things pretty. There are many people who find that interesting, or they might program as their day job, but they also have a sense of playfulness and fun when it comes to coding. And I would say, I'm not sure. I might be in the minority, but I think there is a significant minority of people who are delighted by these kinds of things. And actually, one of the things I talk about in my book is these two stances and approaches towards computing. There's the utilitarian stance and the wondering stance. And the utilitarian stance I identify with building enterprise software, the more corporatized software development, or more like team-oriented work. And then the wondering stance is often a little bit smaller, a little bit playful, oftentimes something you're building on your own. And the truth is, they've always coexisted in computing history, and they've actually fed off of each other. So back in the early days of computers, and a lot of computers were fairly large operations, and it required you being part of a university or a large company, and you really had a distance from the machine. But around this same time, there were mini computers that people actually developed some like their first game of Space War, and they were doing interesting, playful things there. And then once you had the advent of personal computers, you had both personal computers that were found in offices and being used for spreadsheets, but then people were also making games or weird little animations or whatever it was. And the truth is, even now on the web, while we think of the web as a whole bunch of sort of like walled gardens of social media or these large software as a service tools, there is this very large subculture of, some people refer to this as the poetic web, where people are just building fun, weird, and strange websites that are just delightful. And so I think it definitely is the minority, but there's a lot out there. There's people who are doing interesting creative coding experiments, other kinds of things. And there are people who might be doing both. During the workday, they might work on a SaaS product. And then in the evenings, they might make some sort of interesting computational visualization or whatever it is. And so I don't necessarily think it's that there are some types of people that feel one way or another. They might divide their time differently. They might recognize that it has different purposes. And so I feel comfortable probably saying that it's the minority, but I think it's not that small, and there can be a lot more of that. And I think also people might have gotten into coding and computer science for some of these wonder ideas, and maybe just need to be reminded of the initial reason they got into it around these ideas of delight and beauty and playfulness. Because I think a lot of people, they didn't necessarily just get into it because they wanted a software job. Maybe some did, but I think there was also a sense of, oh, this is actually a really interesting medium to be working with.
I know several CEOs that I've spoken to in the last couple of months who they code on the weekend. They started off as software engineers, and now they're running companies. Well, either they code on the weekend, or because they're founders of small companies, they're like, dude, I wrote 10,000 lines of code last week. And they said, the joy of that is something that you can see it in their eyes. And this is exactly what I want to illuminate in this conversation, which is the first-person experience of work. And I'd like to talk to you about how AI is changing coding. I will tell you up front that there's something I hope it will do, which is that in the book you talk about big corporate programs where you have to break it up the problem into lots of little pieces, and now I'm responsible for this subroutine off in the corner that talk about moons around other planets that nobody's ever going to understand. There's just this thing over in the corner. AI might make it possible for individuals to create whole, much more complex pieces of software, and that could potentially really transform the experience of writing software because you don't have to break it up anymore. When people talk about the alienation of labor, a part of what they refer to is the fact that when you have to break up a problem into lots of small pieces, you're no longer connected to what those pieces turn into. And so you feel detached from the outcome, and you don't own the outcome either. The company owns the outcome. And so one of the things I hope anyway is that we'll be able to collapse these giant teams into one or two people.
I would love that. And not only is there this alienation from the final output, if you're part of this large team and only working on a small component, but there's also, probably to a certain degree, a decrease in understanding. Going back to what we're talking about, like when you build these very large, complex technologies, if you're only working on a small piece, and that's the only part that you really have a connection to, it's really hard to understand the entire whole, and there can be downsides in terms of unanticipated consequences. More broadly, I think AI, it'll allow you to kind of get a more holistic sense of some of these systems. It'll allow you to build entire things with a smaller group of people, or maybe even individually. It'll also reduce the feeling of frustration. And so we haven't talked about this yet. And I alluded to a little bit with debugging, which is the process of writing code. It can be very rewarding, but there's a lot of frustration, at least for me. You write things and they don't work the first time. You have to go back and figure things out. And it can be really dispiriting. But AI actually has the possibility of just speeding that up. And I think people have talked about almost like smoothing the speed bumps or whatever it is, and just allowing people to have a greater sense of facility and speed and comfort in writing code, whether it's writing code in a language you're familiar with, writing code in a language you're not as familiar with. Kind of just allows you to do all these kinds of things. In addition to the team-oriented aspect you mentioned in terms of collapsing the sizes of teams, it'll reduce the disconnect between the people who might have an idea for what the software will do versus the people who are actually implementing it. Because right now, there might be someone who in a company says, oh, like we need to do this kind of thing, but they might not necessarily have the skill to actually execute on that. And now with certain AI-assisted coding, whether it's certain versions of vibe coding or however we want to define that, people who might not necessarily have been able to code can now actually build software themselves. And I mentioned this idea, the low floors, high ceilings of Seymour Papert. We now actually see this even more easily in terms of generative AI and coding, or actually even going back to the idea of magic. As much as we talked about magic as the realm of the arcane, there is also a long tradition of folk magic, of spells and incantations that were designed for the everyday user, for recovering lost objects or whatever it is. And I think we need a lot of that. I want there to be the ability for people who don't necessarily feel as comfortable building lots of software to actually be able to implement their ideas in code, either directly or indirectly using AI. And I think when it comes to the future of coding that's enhanced by AI, that will not only allow teams to be smaller, but people who might have had an idea and then traditionally, if they wanted to start a company, for example, or just build something, they might have had to hire a whole bunch of engineers. They could now at least build a prototype themselves. And it would maybe allow companies to go faster, but it also just allows you to prototype things more and more rapidly and just see whether or not they're worthwhile. So like, for example, recently I had an idea for a simple little computer game. And so I was using AI to help me build some of the software. And one, it was just unbelievable, more impressive than I expected. But it also got me to the point where I built the thing so quickly that I quickly realized my idea for a game was just not fun. It wasn't that great of a game. And if I had spent a huge amount of effort, it would have not been nearly as rewarding an experience. But if I can iterate and prototype very, very rapidly, that's really useful and very powerful. Yeah, so I definitely think AI, it has changed coding already, and it will continue to change it in a lot of different ways, from whether it's the team-oriented aspect, the ways in which we think about tech company formation, the way in which we build software just for ourselves rather than having to be for a large group of people. So that there's the novelist Robin Sloan. He talks about this idea that an app can be a home-cooked meal. We don't necessarily need to be working in industrial kitchens. We can build little things for ourselves. And then also the idea that, yeah, that people who might otherwise not have been building software now actually are able to do that. So I think it's going to change things in many, many different ways.
I've been around Silicon Valley long enough that I've seen a recurring pattern. And this is just one instance of it. I remember going to, what were they exactly? Trade shows, I guess. Going to trade shows. These were right downtown San Jose or something like that. For people who are not from the Bay Area, that's the South Bay. And so what they were showing was very rudimentary manipulations of images. These manipulations were like, look, I can twist it. Or look, I can change the contrast. These were like things that were incredibly rudimentary, but because they were being invented right then, these were things that people were showing off. Well, the day came where all of those different manipulations got packaged into something that people who didn't code could use. And then graphics moved from San Jose in the South Bay, and it moved up to San Francisco where the artists were. And the artists got it and started actually applying it to make art. And so this movement from the hands of technologists to the hands of artists, and they set up a whole industry around it. This whole industry bloomed out of, and this is where things like Photoshop came from. In fact, I think this particular trade show was right next to Adobe. So Adobe was probably there saying, look, we can move this pixel in the beginning. So I think this could lead to a similar movement, which is that now, talk about creative media, it's going to make this a lot less like frescoes.
Yeah.
And a lot more like oil paint.
And I think coding and how we think about computer programming more broadly, it has always changed. It's always been kind of a different thing from year to year or generation to generation or decade to decade. And certainly in my mind, I have a certain understanding of what it means to code based on when I grew up and when I started doing those kinds of things. But I think we also just need to not be too precious about those specific modes, because ultimately it's about this process of computational thinking, of taking some idea in your mind and being able to instantiate it in software. And whether or not that can be done by professional software developers, people who just want to use it in service of some other thing, I think that's fine. And so actually one of the stories I use as a way of helping me think about the ways in which programming has changed and is going to continue to change is actually a story from the Talmud. There's this very interesting story where Moses is having a conversation with God, where they're discussing, I think, about who is going to be the greatest rabbi sometime far in the future. And Moses, he is transported 1,000 or 2,000 years into the future, or whatever it is, into the study hall of this great rabbi. And he's sitting in the back and he's listening to this rabbi speak about all these different things. And he realizes he doesn't understand anything of what's going on. And he's dispirited and overwhelmed. And until at the very end, where this rabbi says, oh, and the way we understand this is because the law was given to us by God to Moses from Sinai. And at that point, he's calmed and he realizes, oh, there is this continuity. There is a tradition. In the same way that I don't know how to program in machine code, I certainly don't know how to program the way that Steve Wozniak did some of the early things with the Apple, which when I read about them, they sound mind-bogglingly impressive. And the way I programmed is going to be different than the way people program using AI or in service of other kinds of things. It's all going to continue to change, but it's all part of this tradition of being able to interact with our machines. And going back to what I was saying before, of the quote from the Structure and Interpretation of Computer Programs, ultimately, programming is for people. And the best ways that we have of making sure that we can build software, that should be what programming is. And so I totally agree that ultimately it should be widely democratized. It should be available for artists and designers and middle managers or whatever it is. They should be able to use these things as easily as possible. I want this as wide as possible. Now, certainly I think that some facility with certain aspects of code is also important for certain kinds of things. But what the form will look like, I'm kind of agnostic because I just want people to realize that building software for yourself, it's a means of empowerment and also excitement and delight.
I have a few closing questions that I ask at the end of every show. Because the show is about work as a product, I ask product design questions about work. And the first one is, what job do you, Sam, hire your job to do for you?
I'm obsessed with curiosity and just learning new things about the world. And I feel very fortunate that, so my day job, which is I'm scientist in residence at a venture capital firm where I get to kind of explore various ideas and at the cutting edge of science and technology, I get to indulge my curiosity as my vocation. And I feel very fortunate that I am compelled to actually be curious about lots of different things, learn lots of different topics, read widely, reach out to some of the most interesting people I can think of, and just learn. And I feel really lucky that my job is able to do that for me.
There's not many jobs that would be as good for that as yours.
I feel very lucky.
One of the kinds of people I've always been very impressed with is patent attorneys because they take new ideas and they have to completely comprehend them and then turn them into a document that represents that. But your toes are hanging over the edge of even what's possible. It's like, what's feasible? Where are people going? That's an incredible place to stand.
Yeah. It certainly also allows me, and in addition to kind of curiosity, I'm interested in many, many different things, and I get to think about a new thing every hour or so, which is very nice to be able to lean into that.
What does your job cost you?
So I'm not sure I would say it costs me this, but I would say, so one of the things that I think a lot about is the history of technology. And I actually think there's a great deal of importance in engaging with the history of the computing world, technological history more generally, because I actually think a lot of the Silicon Valley mindset is often ignorant of that history, sometimes proudly ignorant of it. And I would say, if I'm constantly thinking about the new, it's very easy to forget the history of some of these ideas and realize that there's actually a very deep history or a past dependence of why we have the things we have. And so for me, I'm not sure I have to think about the new at the expense of the history. It's more I have to always be deliberate in my focus on thinking about the history of these ideas, because without that, I think we actually lose something.
I can see that first of all, there's this history of why is this weird thing weird the way it is? It's because, well, it came from this, or, the path that it arrived here from required it. It's also this thing I worry about, which is that history is still existing in all the stacks, the stack of technology that we sit upon. And I wonder how many sort of the deep compost layers of that stack we don't understand.
I definitely think there's a lot of that. Yeah, we don't understand those kinds of things, or we don't understand why we have what we have, or people are just constantly reinventing things because they don't realize that there have been some great ideas decades before that are worth revisiting. And so I really try to engage with the history as much as I can, even when playing in the realm of the new.
Actually, sort of the waste of reinvention, I think is one of the things that AI is really going to help with. And the reason is, one way to look at AI is that it's recycled cognition, which is that I don't have to mine new ore. I can go to the junk heap of intellectual and I can just pull it right out. And it's been hidden in the depths of knowledge. And now I can actually reach in and pull it out really rather quickly.
There's a fantastic paper that came out in the mid-1980s called Undiscovered Public Knowledge. And it's exactly this thing. And so this is well before the modern AI techniques. But the idea behind it was, imagine somewhere in the scientific literature, there's a paper that says A implies B. And then somewhere else in the literature, maybe in a different subfield, maybe in a totally different field, there's another paper that says B implies C. So if you combine them, you would learn that perhaps A implies C. But no human has ever read both these papers. And so this knowledge is just undiscovered, but it's public. And so the scientist actually, he used the then cutting edge techniques of keyword searches in some sort of medical database, and he was actually able to find some interesting relationships. But you're right, now with AI, we are able to surface all these things so much more easily. And I think that will actually provide a great deal of context and history, and also recognition that we don't need to rediscover all these kinds of things. We can actually realize that these things have already long been known, but now we can bring them to a much larger audience.
It occurs to me that there's a whole other application there, which is that journals only publish, for the most part, positive results. And so there's this long history of negative results that essentially doesn't make it into the literature. And we should have a place where we can all put our negative results. And no, nobody ever has to read it except the AI.
I like that. I think there was at least one journal. I think they actually attempted to make it a journal of negative results. But I like this idea of, right, the negative results being the reading material for the AI.
Yeah. You know why this magazine went out of business, right?
It's not very exciting, yeah.
Right. I'll bet somebody's working on that. What's your favorite tool of your trade?
I don't know if it's my favorite tool. It's certainly a tool that I think people find curious that I use. So for almost all of my meetings, when I'm meeting other people, especially lots and lots of Zoom meetings, I write everything down manually. I have notebooks. And sometimes I'll maybe transcribe a couple things or email them to myself or write something else afterwards. But by and large, I just write in a notebook whenever I'm having a meeting. And the way I use it afterwards is if I have to look something up, I'll go onto my Google Calendar, find the date, and then and actually at this point I have a whole stack of notebooks that I've created from all these meetings, and then I'll go back and find it, and I can see if I can recover it. Sometimes I cannot actually find it because I didn't write the thing down or my handwriting is too bad. But for me, that act of just writing things manually down while I'm having a meeting makes me pay attention maybe differently. I don't know if it's better or worse, but it's certainly different. And it's something that I've just been doing. And they're not particularly fancy notebooks. I'm showing them to the camera right now. They're kind of just little graph paper notebooks. And then I just have many, many of them, and I use them. So I don't know if that's my favorite tool of the trade, but it's certainly one that I like using.
I get it. You held up the notebook and my heart leapt. I was like, where can I get one of those? So, like I said before you and I started talking, this is the first in what I think is going to be a series of looking at the first person experience of work. And I'm one of the people who built HR systems to treat people like things. And it's a necessary simplification sometimes to turn people into numbers so that you can manipulate them. But it makes us sometimes forget. When I put you into a database, I give you a unique identifier and I count you, and you're one of 10. You're any one of 10, undifferentiated one of 10. You're never less human than when you're N of 10. I don't know. And so it's just easy and lazy of us to forget each of our first person experiences of work. So I really appreciate the conversation today and the book. It was a really, really fun book to read. And the thing about reading the book is that it's constantly reaching in and pulling threads from parts of literature, religious texts, religious practices, Lovecraft. And so it's a beautiful book and it's a joy to read. And you don't have to code to read this book. It's not about that. It's about the experience of discovery and exploration and all of those things. So thank you very much for coming on the show. Where can people learn more about you and the book?
Well, thank you. First of all, this is amazing, and I really appreciate those kind words. My goal was to really make people realize that the ideas of computation, right, they're not just this branch of engineering or this kind of esoteric thing, that they really do connect to language and philosophy and biology and art and all these other wonderful things. The book is The Magic of Code. It can be found anywhere where books are sold. You can find more about it. I actually made a little website called themagicofcode.com. You can also go to my own website, arbesman.net, so just my last name, .net, and you can see my other books and my writings and newsletter and all those other points of contact.
Thank you very much.
Thank you.
Thanks for joining me for another episode of Work for Humans. If you enjoyed this episode, please give us a 5-star rating wherever you listen to podcasts. And share the show with one person you think would get value from it. Believe it or not, this really helps us grow the show and reach more people who want to build the kind of work that people really want. As always, thank you to my producer Jason Ames at Ninth Path Audio for his insights into content and his high standard for quality. Final note, the opinions shared here are my own and not the views of Google or Cisco Systems. Thanks again for listening. See you next time.